Why is there an infinite number of primes? This is a direct proof with two cases. Let's assume that there's a set P that contains n prime numbers denoted P1, Pn. Let's now create a new number, n, which is one more than the product of all the primes in P. Now, there are two options that n could be. The first option, n could be a prime number, and the second option is that n could not be a prime number. Let's look at option 1 first. If n is prime, then P does not contain all the prime numbers, since n is not in P, but is still a prime number. Now for the second case. If n is not prime, then there has to be a prime number that is in P that divides n evenly, since every non-prime number can be prime factorized, or written as a product of prime numbers. We already know that at least one little p in P divides n minus 1 evenly, since n minus 1 is just a product of all the primes in P. Since this little p supposedly divides P, and definitely divides n minus 1, it should divide the difference between the two. This implies that P should divide 1 evenly. However, this is not possible, as no number can divide 1 evenly. This means that there is another prime that is not in P that divides n. In conclusion, the results of these two cases prove that for any finite set of primes, there exists at least one more prime number that is not in that set.